Just confirm if you can hear me. Just confirm if you can hear me. We are live on both TikTok and YouTube. Loud and clear, Lele. Thank you, thank you, thank you, thank you, thank you, thank you. We're just giving others time to join. Now it's 2 past. Let's just give them 3 minutes. We are starting off with the 2023 1.3. If you have got access to the paper, please, you can download for yourself so that by the time we are going through the paper, you will see exactly the questions and everything. Okay. Thank you so much. Thank you so much, guys, for joining me. Thank you. Thank you so much. Thank you so much. We are in 3 minutes. We are starting. In 3 minutes, we are starting. We are starting in 3 minutes. So this is our paper. This is the paper that we are starting with, mid-latitudes. Refer to the infographic below on mid-latitude cyclones. That's the one we are starting with, mid-latitudes cyclones, mid-latitude cyclones. We are starting in 2 minutes. Starting in 2 minutes. Starting in 2 minutes. Starting in 2 minutes. Is the paper clear? Can you see clearly? Is the paper clear, guys? Is the paper clear? Is it clear? If you can check, do you want me to zoom it out or is fine? Is the paper fine? Thank you so much. Welcome, welcome. We are starting in 1 minute. We are starting in 1 minute. It's fine. Thank you, Demon. Thank you. Thank you so much. Thank you so much. All right, all right. All right. About 30 seconds, we are starting. About 30 seconds, we are starting. Thank you so much. Thank you so much for joining in. Thank you so much for joining in. Thank you so much. You can tap the screen. Tap the screen, share the live. Tap the screen, share the live. All right, it's now 5 past. We are starting. We are starting. So the paper that we are starting with now, let me just show you the paper that we are doing today. We are starting. Remember, yesterday we focused more on short questions. Today is the 15 marks one. So this is the paper that we are using today. We are starting with, that is the 2023 Geography Paper 1, NSC. That's the one that we are using. Let's go to 1.3. Under climate and weather. Let's go to 1.3. Under climate and weather. Uh, 1.3. All right, so we have just arrived now. So what is important, guys, when it comes to this question, guys, let me just highlight, refer to the infographic below on mid-latitude cyclone. So the moment you are given an infographic, guys, it's like you are given the answers, guys. It's like you are just being given the answers on a silver plate. That's all I can say. Why am I saying that? Because most of the answers that you are going to get, obviously, they come from the infographic. Okay, this is what we have. We have got this. I'm going to go through it. We also have this. We have got the graph showing average rainfall. We have got the cross-section of the cold front. All right, before we start, guys, there's a comment, the general comment that I want to make. Whenever we are looking at climate and weather, whenever we are looking at climate and weather. All right, let me write here. When we are looking at climate and weather in general, climate and weather, sorry, my spelling there. Okay, our main concern in terms of analysis, in terms of interpretation, we comment on the elements of weather. Elements of weather. You will see it as we go through the paper. Elements of weather. What do I mean by that? We are looking at these four things. Number one, precipitation. Precipitation. Number two, we are looking at cloud cover. We are looking at comment in relation to the cloud cover. We are looking at comment in relation to the wind speed or direction. Okay. We are also direction. I hope the spelling is right. We are also looking in relation to the temperature. Okay, temperature. All right. These are the four things. You are going to see it as we'll be going through this. You're going to see that this is where all your interpretation, all your analysis is centered on. Precipitation, we are talking about the various forms of moisture that falls from the sky to the earth. Are we likely to have rain? Are we likely to have hail? Are we likely to have precipitation form of drizzle? So you are going to see that as we are going to analyze, all the questions, and also going to answer all the questions. So these are the four things that we are going to see that whenever we are analyzing this question, we are commenting in relation to what will be the effect on precipitation, what will be the effect on cloud cover. Are we likely to have an overcast? Are we likely to have clear skies? Okay, wind speed, think of your pressure gradient, steeper pressure gradient, strong winds, gentle pressure gradient, which means they are gentle winds, weaker winds. In terms of temperature, is it cold? A cold front, what weather condition does it bring? Obviously, the temperature drops. I'm just commenting in general. Okay, so is it cold? Is it warm? Is it you see? These are the things that you are going to center your analysis or your interpretation on, the elements of weather. That is your precipitation, which is various forms of moisture that falls from the sky to the earth. It can be rainfall is a form of precipitation, hail is a form of precipitation, snow is a form of precipitation, even drizzle is a form of precipitation. Cloud cover, is it overcast? Is it partly cloud? Is it clear? In terms of wind speed, obviously I'm going now, strong winds, okay, weaker winds, pressure gradient, steeper pressure gradient, gentle pressure gradient, okay. Then the temperature, is it cold? Is it warm? Is it mild? Okay, I wanted you just to have an idea. Of course, this is basically what your analysis will be centered on in as far as weather and climate is concerned. You are going to see that, be it mid-latitude cyclones, be it tropical cyclones, be it subtropical anticyclones, valley climates, or even urban climates. This is where most of your analysis will be centered on. So let's start now. All right, I want to hear from you guys. I'm going to remove this now because I will need to write a lot of information here. What comes to your mind just by hearing the word mid-latitude? What comes to your mind? Just by hearing the word mid-latitude, what comes to your mind? Mid-latitude. Let's start now. Latitude. What comes to your mind? Let's write. Let's participate. What comes to your mind just by hearing the word mid-latitude? What comes to your mind? I'll start. Okay. Low pressure system. Okay. Low pressure system. Okay. I've started. All right. What else comes to your mind? What else comes to your mind when it comes to mid-latitude? Before we start going through this infographic, we just want to do an analysis so that at least we can know, I know that we are moving at the same pace. So I have said one is a low pressure system. What else comes to your mind when you hear or when you see the word mid-latitude? Area of location, okay? Location, area of location. We are talking about 30 to what? To 60 degrees, of course, north and south of the equator. North and, let me just say north and south of the equator, okay? Of the equator. of the equator. This is something that comes to mind. Okay, what else? Movement. In terms of movement, what happens in terms of movement? We are saying it moves from where? From west to what? From west to east. West to east. What else comes to your mind, guys? I need your participation. I need your participation. What else comes to your mind? Why does it move from west to east? It is driven by the westerlies. Driven by the westerly. Westerlies. These are some of the things that should come to your mind when, okay, westerlies, wind belt, of course. What else comes to your mind in terms of characteristics? In terms of characteristics, what else comes to your mind? We want to analyze, guys. We just don't want to start by, we'll go to the infographic. Characteristics. What are some of the characteristics that you can think of? Clockwise direction. Be specific now. If you say clockwise direction in the southern hemisphere. Clockwise direction, of course. Clockwise direction. Of course, I know we are focusing. Clockwise direction or circulation. All right, let me just say circulation. Okay. Where? Southern hemisphere. What else? There is a cold front. Okay, cold front. Yeah, that's correct. You can also think of the cold front. Cold front. What else comes to your mind? Occlusion. That's correct. What else? Clockwise, higher temperatures. Higher temperatures, of course. Presence of warm front. All right, warm front. Okay, warm front. What else? The stages of development. Stages of development, which are stages of development. Stage of development. Circular isobars. That's correct. You guys are cooking. Circular isobars. Okay. What else? Just in general. So the stages of development. Let's just try to list the stages of development. Which ones are they? The stages of development. Initial. We have development. We have what? Mature. And what? And occlusion. Isn't it? Okay. So I said circular isobars. What else comes to your mind? What else comes to your mind? Mature stage, of course. What else comes to your mind? What else comes to your mind? We just doing a breakdown. We are building a foundation, guys. We just don't want to jump into the question without a foundation. We are trying to build a foundation. That's what we are trying to do here. A common understanding, so that when we start reading the infographic, you'll know where we are coming from and where we are going to. Okay, sharp. So we have said just in general. I'm just going to read what we have written down here. It's just a lot of information that has something to do with the mid-latitude. Okay, mid-latitude, we are saying about low pressure system, area of location 30 to 60 degrees north and south of the equator. The movement, we have said it moved from west to east. Why? Because it's driven by the westerlies. Characteristics, we have talked about the clockwise circulation, the southern hemisphere, the cold front, occlusion, warm front, stages of development, which is initial development, mature, and occlusion. We've talked about also the circular isobars. So this is just in general. What I'm trying to do, guys, is before we start, we attempt to answer the question, let's operate from a common ground. That's basically what I'm trying to do here. We want to operate from a common ground where we have got the foundation, general information about the concept. All right, let's go to the question now. Let's go to the question now. I was trying to make sure that we have got a common ground where we are working from. Okay, sharp now. I'm going to read now. I'm going to read now. A well-developed cold front. Here is very important. I'm going to highlight it. Cold front has reached the Western Cape in the morning. So already, by mentioning of the word a well-developed cold front, what comes to your mind? This statement that say a well-developed cold front. What comes to your mind in terms of stages of development? By the first sentence, which says exactly, Kelo, that is your mature stage. You understand? That is your mature stage. So that's the mindset that you're supposed to have. By reading, you connect the dots. You connect the dots. Thank you, Kile. Thank you, Kile. That's correct. So that's what comes to your mind now. When it says a well-developed cold front, what should click in your mind? Oh, in terms of stage, that is the mature stage. Thank you. Let's move on now. It brought rainfall which spread to the southern western part of Eastern Cape. Okay. It brought rainfall which spread to the southwestern parts of Eastern Cape and Cape Algahas and reached the southeastern parts of the afternoon. All right. From this second part now, what comes to your mind? From this second part here, what are they trying to imply here? Where in terms of its movement, what is the implication? What can you say in terms of movement? Where they say it brought rainfall which spread to the southwestern parts of Western Cape and reached the southeastern parts late afternoon. What comes to your mind in terms of its movement? What comes to your mind in terms of its movement? Exactly, Demon. That is west to east. You guys, can you see how I'm picking these things? If you do not have a critical mind, you cannot pick these things that I'm picking. So already it is suggesting to you that it moved from west to east. If you can look at this, it's moving towards these guys, which means west to east. That's basically what this is all about. So you should be able to pick these things from your infographic. Are you following, guys? Are you following? Give me a thumbs up if you are following. Give me a thumbs up if you are following. Just a thumbs up, just a thumbs up, just a thumbs up. I want people who are alive. Give me a thumbs up if you're following. Thank you so much. Let's read. Let's continue reading. The bulky of the rain fell over the southeastern parts, that is Mose Bay, Krishna, and of the southern coast from the afternoon into Friday morning, where rainfall increased over. So what is telling you now here, from the part which says the bulky of the rainfall, you all know that your mid-latitude is also associated with what? What? Floods, torrential rainfall, floods. So that's something that should come to your mind, because they are saying that it lasted what? Increased over 36 hours. So already what is coming to your mind now is, it's possible that there were floods. It's possible that there were what? There were floods. It's possible. You understand? So we have picked three things. Number one, that the stage of development is mature stage. Number two, that the movement is west to east. Number three, the impact, which means the flood is coming off as an impact of flood. What do we have? What are some of the impact of the mid-latitude? Obviously, from here, we are saying floods. But this, we have derived it from the infographic. Okay. Are you following, guys? Are you following, guys? Are you following, guys? Are we together? Are we together? Okay. You can also check from here. I want to show you something. Every information that you have is very important. Can you check here this word? Warnings. Here. Oh, no. Can't see what's happening. Can you check? Change. All right, sharp. Can you check from here? All right. Here. Where is written warnings? Here. Warnings. Oh, I don't know what's happening here. Okay, sharp. Here under this one, adapted from www.weatherssa.co.za, warnings. Obviously, we are looking at what? What are we looking at? These are the likely impacts. What has the mid-latitude brought in? So obviously the word warning, we are saying now here, we are talking about the floods. Let's move on to the map showing now. The map showing the affected area. Affected area, this is the affected area here. This is the affected area. This is how it's moving from here, from west to east. You see, this is how it's moving, which means here we are saying now it moves from, we have already come to that conclusion that it moves from west to east. We have already come to that conclusion. We are seeing that as well, even from the map showing the affected area. With the map showing the affected area, let's move on to the bottom now and see what we have. The average rainfall. The average rainfall, graph showing average rainfall. You can see from Cape Town. Can you see how the amount of rainfall is increasing? Of course, from Cape to Cape Algahas, to Mose Bay, to Krishna, you can see what is happening. You can be asked about the amount of rainfall received in Cape Town, the lowest and the highest. You can be asked about that. So this is very important. You have to take note. You have to pick this thing. This is very important. Okay. And then lastly, what we have, the cross-section of a cold front. Most learners, you make mistake when you're doing the cross-section of a cold front. What mistake do you make? you include the symbols. When you are doing a cross section, please make sure no symbols. Okay. When you are doing cross section, please make sure no symbols. You don't put the symbol for the cold front. You don't put the symbol also. You don't put the symbols. That's basically what we are talking about. So here, this is an example of a cross section of a cold front. What do we have? So this is your cold front here. Behind the cold front, there is code A. These are some of the things that you're supposed to know in general. Behind a cold front, okay, there is code A. Code A. There is code, let me just check my spelling. There is code A. Behind A, code front, there is what? There is code A. These are some of the things that are basic that you should know. Behind A, code front, there is what? There is code A. Ahead, obviously, there's warm A, which means ahead, obviously, ahead, these are basic. Ahead of code front, there is warm A, which is your warm sector, So these are some of the things that you should know. These are some of the things that you know. Ahead of the code front, there's warm A. Behind the code front, there's code A, which is your code sector. So here, there's where we have got our warm A. Obviously, this is a cumulonimbus cloud. Here, that is your cumulonimbus cloud. Cumulonimbus cloud. Okay. Cumulonimbus clouds, obviously, it is associated with heavy rain. Associated with what? Heavy rain or torrential rain. Torrential rain. Heavy rain. That's what it is associated with. Torrential. Let me just fix my spelling here. All right, let me fix my spelling. Torrential. Okay. So these are some of the things that you can pick. I'm just talking about what we have in as far as the infographic is concerned. So this is what I have picked from the information that I have. I have read this, and from this diagram, from this paragraph, I have picked up that it is talking about the mature stage. I have picked the movement that is moved from west to east. I have picked the likely impact that is floods. It is associated with heavy rainfall, which can result in floods. I have also looked at how the areas that were affected, and I have also come to the conclusion that in terms of its movement, moved from west to east. I have also looked at the rainfall, of which I'm not sure what they're going to ask about, but these are the recordings in millimeters, the unit of measurement of our rainfall, which is a form of precipitation for these areas, okay, that was affected by the mid-latitude or the cold front. I have also picked that from the cross-section of the cold front, I do not need to include symbols. I have picked that behind the cold front, there is cold A. I've picked that ahead of the cold front, there is warm A, which is your warm sector. I have also picked that there is a cumulonimbus cloud now, which results also obviously in heavy rains. That's basically what we are talking about. Okay, so let's go to the question now. What is the answer for number 1.3.1? What is the answer? What is the answer? The mid-latitude cyclone mentioned in the extract is in there. What is the correct answer? 1.3.1. What is the correct answer? Mature stage. Where did we get that? Remember, when we were analyzing, we picked it already when we were reading the statement. So it's the mature stage. Okay. That is the mature stage, which means our answer here is what? Mature stage. Mature stage. That is our answer there. All right. So number 2 is saying, give a reason for your answer. Why are you saying it's the mature stage? Can you see? Let's go back. It's saying a well-developed cold front. A well-developed cold front. So that is the reason why that supports that it's a what? It's a mature stage. Okay. A well-developed cold front. Okay. Well-developed cold front. All right, guys, let's not rush, guys. Let's not rush. Let's just do one step at a time. Let's not rush. Let's not rush. Let's not rush. Kile, I think the correct answer is a well-developed cold front. Well-developed cold front. That's what supports. That's what supports there. You can also talk about the widespread of rainfall in the Western Cape, where it's moving. Okay. Okay, well spread rainfall in the Western Cape. Of course, this is where we receive most of the rainfall in the mature stage. You can also talk about the steeper pressure gradient. These are some of the things that you can actually talk about. Okay, all right, sharp. But this is what I prefer more, a well-developed cold front. I prefer this one more. Okay. Okay, are we together, guys? If we are together, give me a thumbs up. I hope I didn't confuse anyone. Are we together? Give me a thumbs up if we are together. Okay, sharp. Let's move on to 1.3.3. It's saying, why did the rainfall mentioned in the extract spread from Cape Town to Mose Bay and Krishna? Why did it spread? Okay, why did it spread? Remember, we said it spreads in this direction from west to east. Why did it spread in that direction? What is the answer? Why did it spread? How does a, okay, exactly, widespread from west to east? A what? A mid-latitude move from west to east. A mid-latitude, okay. A latitude move from west to east. Or you can say driven by the westerlies. Driven by the westerlies. Westerly wind belt, okay, whichever you put it. Okay, that's basically what you can include there. Driven by the westerly wind belt. You can talk about that. Are we following? Are we following? Are we together, guys? Give me a thumbs up if we are together on 1.3.3. Give me a thumbs up. Give me a thumbs up. Are we together? Sharp. Let's move on to 1.4.4, 1.3.4. Refer to the graph. Refer to the graph. Okay. Refer to the graph. Refer to the graph and determine the lowest and the highest rainfall. Remember, guys, I talked about this when I was explaining here. Refer to the graph. We want the lowest and the minimum. Which one is the lowest amount of rainfall and which one is the minimum recorded? We are referring to this graph. Which one is the lowest? The lowest amount and the maximum. Which one is it? That is 1.3.4. What is our answer then? What is our answer? What is our answer then? Refer to the graph and determine the lowest and the highest rainfall in millimeters recorded. Okay, you want me to zoom? No problem. All right. Which one is the minimum? Okay, we are saying refer to the graph and determine the lowest and highest rainfall recorded in millimeters in Western Cape over 36 hours. Which one is it? So we have got the lowest. Okay. Yeah, we want here. Okay, let's go to, all right. So the lowest, let's write it down. Lowest is what? 15, isn't it? 15 millimeters. Okay. And the highest is what? 40 millimeters. Are we together? Are we together, guys? Are we together, guys? Are we together, guys? Are you following? So we have got the lowest and then highest. Where did we get the answer from? Here, Cape Town, 15 millimeters. Then we've got Nesna, we've got what? 14 millimeters. Are we together? Thumbs up if you understand. Thumbs up so that we can move. Thumbs up if you understand. Thumbs up, thumbs up, thumbs up, thumbs up. Let's move. Okay, sharp. So we are now on 1.3.5. It reads, with reference to the cross-section, explain how a well-developed cold front results in heavy rainfall over Western Cape. Okay. He said, with reference to the cross-section, explain how a well-developed cold front results in heavy rainfall in the Western Cape. With the reference now. Let's go back. Let's go back. Let's go back. This is what we are using. So it's saying, with reference to the cross-section, explain how a well-developed cold front results in heavy rainfall over the Western Cape. How best can you answer this question? With reference to the cross-section, explain how a well-developed cold front results in heavy rainfall over the Western Cape. The cold air forces the warm air to rise. Of course, I can take that one. I prefer the word undercuts. Please try to use the geographical term, but it's correct. You can get your mark there. A cold front, what does it do? It undercuts the warm, moist air. What happens when the warm, moist air is undercut? It rises, cools, condenses. Then we have got what? Cumulonimbus clouds. Are you following? Then after the cumulonimbus clouds, we have got our heavy rainfall. That's what happened there. So let me write it down. Let me write it down. Let me write it down here. Okay. Okay, let me write it down so that at least we move at the same pace. Cold front, cold air, whichever you prefer, or cold air, more or less the same thing. Okay, undercuts the warm, moist air. Okay, then it rises and condenses, forming cumulonimbus clouds. Low nimbus clouds resulting in heavy rainfall. Heavy rainfall. Heavy rainfall. That is the simplest thing. That is the simplest explanation that you can give, okay? The simplest explanation that you can actually give. So we are saying now, the cold front, I'm just trying to make sure that this becomes more visible. The cold fronts undercut the warm moist air, causing it to rise, condenses, forming cumulonimbus clouds, resulting in heavy rainfall. So this is the answer for your 1.3.5. You want me to zoom? Okay. So here, how will the reference to the cross section explain how a well-developed cold front results in heavy rainfall? So we are saying now, okay, we are saying now, when you're looking at this diagram, what happens? The cold air or cold front, it undercuts the warm air, causing it to rise. As it rises, it condenses. As it condenses, clouds form to be specific cumulonimbus clouds. Then we have heavy rainfall. That's basically what we are talking about. So this is what is happening here. Remember here, there's steeper pressure gradient behind the cold front. So the cold air is dense. So what does it do? It sinks. Warm air is very light. It rises. So the cold air, what it does is it undercuts the warm air. When the warm air is undercut, okay, it rises. As it rises, condensation takes place. Clouds form to be specific, what? Cumulonimbus clouds. Then we have got our heavy rainfall. So that's the explanation. Are we together, guys? Give me a thumbs up if you understand. Give me a thumbs up if you understand 1.3.5. Give me a thumbs up, guys. If it's clear, give me a thumbs up. Okay, sharp. Let's move on now to 1.3.6. How will the heavy rainfall negatively affect the physical environment in and around Western Cape? Remember, guys, most of you make a mistake here. Focus, let me just say here, you end up talking about the effects on humans, the economic effect. The focus is on effects on physical / natural environment. Okay, natural environment. Okay, this is the focus, guys. You focus on the physical, the natural environment. Please take note. How best can we answer this question? No. Infrastructure is not part of the physical environment. Infrastructure, this is what I was trying to say. It's saying the physical, natural environment. Infrastructure is not part of the physical, natural environment. It's wrong. Soil erosion and land degradation, that is the natural environment. Nyasha, infrastructure is not part of the physical environment. So the correct answer there, Kelly, you are right. Soil erosion and land degradation. What is the other effect? Destruction of animal habitats. Destruction of animal habitats, you can talk about it. What is the effect on biodiversity? What will that flooding do to the natural environment? What will that flooding, that's what we need to do, to know. Flooding is there, but what will that flooding do to the natural environment? What will that flooding do to the natural environment? Guys, are you following? Are you following, guys? The physical environment, heavy rainfall, drought, let's take it out. Let's take it out. We are talking about heavy rainfall. What effects is it causing on the natural environment? You started well. We are talking about soil erosion and land degradation. I take that one. What else? Flooding will destroy vegetation. Exactly. Flooding will destroy vegetation because I want the effect on the natural environment. Take away crops. Crops are grown. They are not natural. Crops are grown through farming. So they are not natural. So crops is not part of natural environment. We are talking about the natural vegetation. So if we talk about crops, guys, it's not part of the physical natural environment because crops, we grow them through farming, through agriculture. We want the physical environment. That's what we need. We want. Okay? Focus effects on the physical natural environment. So if we talk about crops, crops, they are grown through agricultural farming. They are not natural. We grow them. Floods will wash away plants, of course, uprootment of natural vegetation. That is to the physical environment. Okay, what else? What else? I'm reading. Flooding, destroying trees. Okay. What else? What else? What else? What else? What else? What else can happen? Low-lying areas are flooded, of course. Of course, let's take it like that. Okay, what else? Loss of wildlife. That is the natural environment. All right, I'll check flooding is fine. Loss of wildlife. What else? Okay. Are you following, guys? Are you following? Give me a thumbs up. Are you getting my analysis? The physical, natural environment. The moment we talk about crops, guys, crops, we grow them through agriculture. They are not natural. So what will happen to the vegetation? What will happen to the animal habitats? What will happen to the soil fertility, the natural, through soil erosion, coastal damage, anything that is within the natural environment? If you link your answer to that, then it's correct. Are you following, guys? I hope I'm not confusing you. Are you following? Okay. So if a question says natural environment, don't talk about infrastructure. Don't talk about, don't bring about social impacts. Don't bring about the economic impact. It's saying the natural physical environment. Okay. Do we all understand 1.3.6? And also, did we pick the mistake that we were making? Okay. Did we also pick the mistake? Loss of wildlife, that's correct, is to the natural wildlife within the wild. Okay, what else? Okay, I think we are done with this question. Are we fine with 1.3.6? And do we all understand? I hope I didn't confuse anyone. Are we fine there? Okay, thank you so much. Let's move on to 1.4. Let's move on to 1.4. Can we give me a thumbs up if you want us to move to the next one, 1.4? 1.4? 1.4, can we move to 1.4? Thank you. All right. So 1.4, what do we have? All right. 1.4, what do we have here? So what we have now, the satellite image of the tropical cyclone. The satellite image of the tropical cyclone. All right, let's just talk in general about tropical cyclone, the same way that we did with mid-latitude. Let's just talk in general about the tropical cyclone. Let's just list some things about tropical cyclone. Anything that you can that you can remember that is in your mind. Let's talk about tropical cyclones. I'll start low pressure system. This one is the easiest one. Low pressure system. Okay. What else can we write? Let's start now. Let's just list everything that we know about move. Okay. We are saying it moved from east to west. Okay. That's correct. What else can you write? What else? Why does it move to west, east to west? is driven by the easterlies. Driven by the easterlies. Easterlies. Okay. What else? What else? Anti-clockwise way. Peter, anti-clockwise way is in the southern hemisphere. Be specific when you talk about anti-clockwise. In which hemisphere? In the north southern hemisphere, low is what? Is clockwise. in the southern hemisphere is clockwise. Okay, named in alphabetical order. Named in alphabetical order. Alphabetical order. Okay. What else? What else can we write about? What else can we write about? Okay. All right. All right. Someone's talking about the seasons. Okay. Intense low pressure. Okay. Intense low pressure. Okay. What else can we write about? Common over. Okay. Common over. Warm oceans. Okay. Okay. We are listing. All right. Just want to make sure. All right. What else can we write about? Are you serious, Peter? 30 to 60, that is mid latitude. 30 to 60, that is mid latitude. That is mid latitude. That is mid latitude. 30 to 60, what is the area of location of our tropical cyclones? What is our area? Not zero. Remember, from 0 to 5, there is no Coriolis effect. So it starts from 5. It starts from 5. Tidiso, it starts from 5. It starts from 5. Let's say from 5 degrees northern. Thank you so much. 5 to 30. Because from 0 to 5, there is no Coriolis force, which is a force that is responsible for the deflection of winds. Thank you so much. So it's not from 0 to 30. It starts from 5. Because from 0 to 5, there is no Coriolis force, which is a force that is responsible for the deflection of winds. What else? What else? What else? What else? What else? Turns east at 30 degrees. That's correct. What else? What else? What else? What else? So it shows me, in other ways, how about the stages of development? Let's talk about the stages of development. Just in mentioning stages of development. Stages of development. Do you remember them? Stages of development. Initial, okay, extratropical, that's correct. Of course, let's just type them in order. Which one are the 4 stages? Formative stage, formative. Then after formative, immature, mature. Then what do we have? The dissipation stage. Are we together? We are talking about formative. We are talking about formative, immature, mature. Then we have got dissipation. Okay. Okay, when it dissipates. Okay. So so decaying stage. Decaying stage, that's correct. Okay, it disappears and requires warm air. There's no more air. Regenerating stages, of course, thank you. More moisture, thank you. So from what we have listed, guys, I'm happy that we know what a tropical cyclone is. Remember, we want to work towards common understanding. That's the first thing that we are doing. We don't want just to assume everyone knows. But from what you have listed, it shows me that you actually know what a tropical cyclone is. Okay, sharp. So let's go now. Let's analyze our satellite image now. Let's analyze our satellite image. I'm going to delete this. Let's analyze our satellite image. I'm going to delete this now. Let's analyze our satellite image. All right. Let's analyze our satellite image. So what can you see on this? Can you see the movement? Can you see the movement? Can you see? I want to show you something. In which hemisphere do you think this is? In which hemisphere do you think it is? In which hemisphere do you think this is? In which hemisphere do you think this is? Let's just start the hemisphere. From what I've shown you now, in which hemisphere is it? Southern hemisphere. Thank you so much. Why? Can you see here? It's clockwise. That's why we have come to the conclusion to say that it's southern, because the circulation here is what? It's clockwise. That's why we have said it's southern hemisphere. What do we have here at A? What can you pick at A then? What can you pick at A? What do we have at A? That is the eye. Okay? That is the eye. That's correct. So, since you have seen that is the eye, which stage do you think this is? Which stage do you think? Stage of development? Stage of development? Do you think this is? Which stage of development do you think this is? Which stage of development do you think this is? Okay? It's mature stage. That's correct. Why? Because there's a well-developed eye. Okay. What are some of the conditions within the eye? The conditions within the eye. What are the conditions within the eye? Let's talk about what are some of the conditions within the eye. What are some of the conditions within the eye? Dry conditions, okay? Dry conditions, okay? No winds, that's correct. What else? No clouds, that's correct. No rain, that's correct. Okay. You guys are cooking. You guys are cooking. We are talking within the eye. We have got the eye wall, I know, but I'm talking about the eye. Within the eye, there's someone who's saying, there are clear skies. Okay, clear skies. Okay, they are clear skies. Okay, sharp. There's cold air that is descending. Cold air subsiding. Subsiding. Okay. Descending air results in. Okay, thank you so much. Thank you so much. Thank you so much. Thank you so much. So these are some of the things that you can pick. These are some of the things that you can pick. What can you say about the weather conditions on the left-hand quadrant? Weather conditions in the quadrant. Weather conditions. Weather conditions in the left quadrant. What are some of the weather conditions in the quadrant? We are moving on now. The weather conditions in the quadrant. In this forward left quadrant, what are the weather conditions here? What are the likely weather conditions in the forward left quadrant? What are the weather conditions? Let's talk about them. What are the weather conditions in the forward leading left quadrant? What are the weather conditions here? What are the weather conditions? Heavy rainfall. Heavy rainfall. What else? What else? We have strong winds. Okay. What else? What else can we talk about? Of course, heavy rainfall is coming also with floods. Of course, we can talk about floods, all right? It's fine. What else? Hurricane force winds, okay? Hurricane force winds, okay. What else? Thunderstorms, okay. Thunderstorms. I think you are right now. I think, guys, now you are right in as far as the tropical cyclone is concerned. Let's answer the question. I think from there's a steeper pressure gradient, of course, we're talking about all those things. I think in as far as this satellite image, you are ripe enough now. Let's go to the questions. Let's go to the questions. Let's go to the questions. Okay. State one conditions required for the development of the tropical cyclone. State one condition required for the development of the tropical cyclone. Which conditions are required for the development of tropical cyclones? Let's talk about them. We are doing first question 1.4.1. Which conditions are required for the development of tropical cyclone? Which condition? For the development, guys, please. Condition required for the development of tropical cyclone. Which conditions are necessary? The oceans must be warm. Let's say warm ocean with temperatures above 27 degrees. That's correct. Is there supposed to be more or less friction? Guys, is it supposed to be more or less friction? Is there supposed to be more? I think you are confusing something here, guys. Is there supposed to be, in terms of friction, it's supposed to be less friction, guys? Because if there's more friction, it means that's what causes to die out. There's supposed to be less friction, guys. Remember, when it reaches land, it dissipates because there is more friction. You understand? When it reaches land, that's how it dies out. That's how it loses strength. So it's supposed to be less friction. That's a condition that is needed. It can be more because obviously when it reaches land, that's when, because of more friction, that's how it dies out. So it can be more friction. It's less friction. It's less friction. What else? More moisture, of course, over the ocean. What else? Do you understand this point, guys? We are saying it's supposed to be less friction, not more. Less friction, not more. It's less friction, not more. Less friction. What else? Presence of Coriolis force. Presence of Coriolis force. Coriolis force. Okay. What else is needed? Temperatures above, let's say, 27 degrees. Okay. 27 degrees. What else is needed? High humidity, of course. The ocean must be warmer. Okay, sham. So I think this one we are fine, guys. This one we are fine, I think. This one we are fine. This one we are fine. Are we fine with 1.4.1? Okay, are we agreeing on that there's supposed to be less friction? Can you give me a thumbs up if you agree? There's supposed to be less friction for it to develop. Are we agreeing, guys? Let's agree first before we go to 1.4.2. Are we agreeing that there's supposed to be less friction? Because the moment there's more friction, which means it will dissipate. You understand? It will lose its strength. Thank you so much. Let's move on to 1.4.2. 1.4.2. I don't want to confuse you guys. That's why I'm trying to do this. I have to be very careful with what I'm saying. In which hemisphere is this? We have already talked about this. In which hemisphere is the cyclone, did this cyclone develop? Southern hemisphere. I'll just say SH. Where is this coming from? Can you check here? Check here. That's what I was trying to demonstrate here. That is clockwise. That's what I was trying to demonstrate here. So it's southern. It's southern. That is southern. Okay, southern hemisphere. Give reason for your answer. I've already said it. Circulation is what? Is clockwise. Clockwise circulation. Clockwise circulation. It's clockwise circulation. Thank you. So that is straight into the point. Let's move on to 1.4.4. 1.4.4. 1.4.4, it says differentiate between cloud A and B. Differentiate between cloud A and B. Let's go back. Differentiate between cloud A and B. What is the difference between cloud A and B? Cloud A What is happening at A, cloud A? It's at the eye, which means air is descending, heating up, resulting in no condensation and no formation of clouds. That's what is happening at A. At B, what is happening is the eye wall. Okay. Then at eye wall, what is happening? Air is rising, resulting in condensation and formation of clouds. So we are saying here, let me go back to, all right. We are saying, all right, A, A is the eye. Okay, what is happening at the eye? Air descending, subsides. Okay, all right, no clouds. Okay, then at B, eye wall. Okay, so let me just try to use eye wall, air rising, air rising. Then when it's rising, what happens? We have condensation, condensation. Then what happens? Formation of clouds. Formation of clouds. Okay, are you following, guys? Are you following? Are you following? Are you following on this one? Are we together? Are we together, guys? Are we together on this one? So A is the eye, air is subsiding, no clouds. B is the eye wall, air is rising, condensation, then there's formation of clouds. Are we following? Are we following, guys? Are we following? Are we following? Give me a thumbs up. Give me a thumbs up. Give me a thumbs up. Obviously, on the eye wall, we have got the cumulonimbus clouds. On the eye wall. Close. On the eye wall, we have got the cumulonimbus clouds. But as you move away, we have got the cumulus, then we have got the cirrus clouds. So on the eye wall, we have got the cumulonimbus clouds. If it's fine, give me a thumbs up so that we can move on. Give me a thumbs up so that we can move on. If it's fine with you guys, can we move on to 1.4.5? 1.4.5? Are we together, guys? Are we together? We are saying here in A, no clouds. You understand? We are saying no clouds here. Here, obviously, we are having cumulonimbus clouds on B. Are we together, guys? Okay, sharp. Okay, sharp. Let's answer. Explain why there is a difference in cloud cover at A and B. A, we have already talked that there is air that is descending, cold air descending, resulting in no rainfall. Then on the eye wall, what is happening? We have got air that is rising, that is also resulting in the condensation and formation of clouds. That is your 1.4.5. Are we together, guys? So it's more or less what we have talked about. Here we can just say A, clear skies, and B, dense cumulonimbus cloud cover. Then we take this to be like an answer for 1.4.5. So it's the same thing. It's the explanation, okay? If it's fine, just give me a thumbs up. Sharp. Let's move on to 1.4.6. Why are the strongest winds? Why are the strongest winds found on the forward-leading left-hand quadrant? Why do we have the strongest winds here? Why do we have the strongest winds here? Why do we have the strongest winds here? On the left quadrant, why do we have the strongest winds? Why do we have the strongest winds? Why do we have the strongest winds on the left-hand quadrant? Why do we have the strongest winds? Let me hear from you. Answer for 1.4.6. Why do we have the strongest winds on the left-hand quadrant? Before I type it, why do we have the strongest winds? Why do we have the strongest winds? 1.4.6, 1.4.6, guys. Let's answer 1.4.6. Why do we have the strongest winds on the left-hand quadrant? Why do we have the strongest winds? Why do we have the strongest winds on the left-hand quadrant? Why do we have? Okay. Combination of forward movement and rotation of the system. And steep pressure gradient. Okay, these are the two reasons. Okay. It is steep pressure gradient. Yeah, Kelly, you are cooking. Nice. I like it. Steep pressure gradient. I like it. Combination of forward movement and the rotation of the system and the steep pressure gradient. Guys, this is just 2 marks. I think we are fine with this one. Let's move on. So this one now is asking us, I'm not sure if I'll be able to draw it nicely. It says, draw a sketch of the tropical cyclone in the mature stage as represented on the synoptic weather map. Indicate the following on the sketch map. The air pressure reading at the center of the cyclone, at least 4 isobars indicating the correct spacing, symbol to represent the tropical cyclone. So you're going to end up with something like this. I don't know if I'm going to draw it nicely. I'll try. Okay. You're going to have something like this. All right. Let me see if I'm going to draw it nicely. Of course. Let me see if I'm going to draw it nicely. Okay. Let me see if I'll be able to draw it nicely. Let me see if I'll be able to draw it nicely. Okay. Let me see if I'll be able to draw it nicely. Okay. All right. Let's see now. I just want to see something. What do we have here? All right. What can we write here? Okay. Here I'm gonna say this is gonna be something like something like this. Okay. Something like, okay. Then I'll say, yeah, I'm gonna write. What can we write here? Let's say this is the mature stage. Let me say 976. Okay. All right. Let me just try to write it here. 976. So you are going to end up with something like this. I don't know if you understand, guys. So the question is saying, I've tried. Can you see here? There's a steeper pressure gradient here. You can see the isobars here are more wide spaced. But here you can see the steeper pressure gradient. Of course, that's where you've got your left quadrant there. Okay. So if you check here, it's saying air pressure reading at the center of the tropical cyclone in the mature stage is far below. Remember, the first one, formative, is above. Then immature is below. Then mature is far below. Then it goes up. So you have to take note. Your pressure here, you can see here, this is the sign. Of course, for tropical cyclone, you can see here. Okay, your eye, of course. Then these are the isobars. Are you following, guys? Are you following for 1.4.7? Are we together? 1.4.7. Are we together, guys? Is it clear? I know my diagram is not that nice, but at least there is an idea of how you are supposed to do it. Give me a thumbs up if you understand. If you understand, please, thank you so much. Let's move on to the next one. Can we move on to 1.5? Give me a thumbs up. 1.5, can we move on? Thank you so much. Let's move on to 1.5. Sharp. Okay. All right. 1.5, what do we have? So let's try 1.5. What do we have? We have got the Bergwins now. All right. Which season is this? Let's analyze. Which season is this? Season? Which season is this? Let's talk, guys. Which season is this? Guys, how can it be summer? With this is your Kalahari High. How can it be summer? Are you serious, guys? Kalahari High, more dominant. I serious, guys? It can't be summer. It's winter. The season here is what? The season is what? It's winter. Guys, whenever you see an H inland, it shows you that the Kalahari, it's Kalahari. This is during winter. When you see the high pressure here, it means it's during winter where your Kalahari is very hectic. Are you following? When you see this in the interior on your synoptic weather map or whatever sketch, this shows you that it's what? It's winter when the Kalahari is more dominant. Njokozo, are you getting it? Are you getting it? Winter presence of the Kalahari. Njokozo, can you confirm if you understand now? The dominance of the, if you have got an H inland or in the interior, it tells you that the Kalahari High is very dominant. So that is the winter season. And also your Bergwins, obviously, they okay during the winter season. That's basically what you're talking about. So let's try to define now. Okay, we have said that this is your Kalahari High. And here, what is this one at the, where we have got our L? This one, what do we call it? Coastal low. We call it what? Coastal low. Okay, sharp. So we have got the Kalahari High, more dominant, we have got the coastal low. So these are the conditions that favors the development of what? Of Bergwins. The presence of your Kalahari High and also of your coastal low. This is what favors the development of the Bergwins. Let's try to define what are Bergwins. What are Bergwins? Let's define. You want to know what they are. What are Bergwins? Hot dry winds, of course, hot dry winds is still incomplete. Let's just finish up. Hot dry winds. Hot dry winds is still incomplete. Let's just write it in full. They are hot dry winds, I agree. Hot dry winds is incomplete. The definition is incomplete. Hot dry winds. Which blow from the interior to okay, what dry winds which blow in the interior, all right, sorry, which blow from the interior to the coast. Okay, interior to the coast, of course. All right, we can put it like that. Of course, our interior, this is where we have got the Kalahari High. Interior, where we have got what? The Kalahari High. The Kalahari High. Kalahari High, or over the plateau there. Okay. Then our coast. This is where we have got what? The coastal low. That's where we have got the coastal low. That's where we have got the coastal low. All right. I'm trying to simplify it, guys. I'm trying to make it as simple as possible. Okay. So this, okay, actually in winter, you can also, okay, in winter, okay. What dry winds which blow, okay, which blow from the interior, okay, from the interior, that Kalahari High or the plateau, to the coast, that is the coastal low. I'm trying to make it as simple as possible. So in order for us to have our berg winds now, we need two conditions. We should have the Kalahari High, and the what? And the coastal low. These are the two things that we need. The Kalahari High and the coastal low. These are the two things that are needed in as far as the formation of berg winds is concerned. Okay, so berg in Afrikaans, I think, is mountain, right? Just to add means mountain. So these are mountain winds. In other words, these are mountain winds. Okay, so what happens now? We are saying now they are blowing from the Kalahari, which means from here. Let me try to draw. They are from here towards what? Towards here, at the coast. That is where we have got the coastal low. So when they are blowing from, okay, I want to add something. When they are blowing from land to sea, we call them what? Offshore. We call them offshore winds. Offshore winds. Of course, we call them offshore. They are warm and dry. Do you understand this part, guys? We call them offshore winds. They are warm and dry. So on this side, we call them offshore. Okay. But as they rotate now, remember it's clockwise. On this side, they are from the sea towards the land. We call them onshore. On this side, we call them what? Onshore. Onshore. Onshore winds. Okay. Because they are blowing from sea to land. And they are warm and moist. Are you following, guys? Are you following? I want to see if you are getting what I'm trying to do here. What I'm trying to do here. We haven't started answering the question. I want you to tell me if you understand what I'm trying to do here. Here they are blowing from the interior, that is Kalahari High, towards the coast. So they are blowing from the land to the sea. We call them offshore winds. They are warm and dry. But as they move in a clockwise, now you see on this side now, we call them onshore winds because they are blowing from the sea to the land. They are warm and moist. Are you following? Are you following? Give me a thumbs up if you are following. Give me a thumbs up, guys, if you are following. Give me a thumbs up if you are following, guys. Thank you, Tidiso. Thank you, Ethan. Prudy, thank you. It's clear, eh? So you need to know. They can ask you that here, why are they called offshore? On this side, they are blowing from the land to the sea. From the land, obviously, they don't have much moisture. Remember, what these winds are doing now is, is what we call the dry. Okay, let me just write it down. I'll explain now. Adiabatic lapse rate. Okay, what we call the DALR. Okay, what it says is for every decrease in altitude by 100 meters. Okay, altitude, let me just say here, by 100 meters, the temperature increase by 1 degree. By 1 degree. Okay, that is what we call the dry adiabatic lapse rate, which means as the air is descending down the mountain on the leeward side, what it does is the air is compressed and it heats up. So we call that the dry adiabatic lapse rate or adiabatic warming. We call it also what? Adiabatic warming. We call it adiabatic warming. Okay, adiabatic warming. So this is why it end up causing veiled fires here. That's why it end up causing veiled fires. Okay, that's why it end up causing veiled fires at the coast, because as it is descending down the mountain on the leeward side, what happens is for every decrease in altitude of 100 meters, the temperature increased by 1 degree. Which means what I'm trying to imply is, let's say, I'm just going to give this as an example. It might not make sense. Let's say maybe here it's 20 degrees. Then maybe when it gets here, let's say maybe it's around, this is just an example, guys. Let's say 36. The reason why the temperature has changed, here it's cold. Remember, cold air, what it does is it sinks. There is dominance of your Kalahari in the interior. So when it's sinking, it is adiabatically warmed, which means for every decrease in altitude of 100 meters, the temperature increased by 1 degree. That's why you see here it's 20, but as you get to the coast here now, it's 36. It has been adiabatically warmed. The air is compressed. It heats up. That's why now these higher temperatures at the coast now will result in veiled fires. Are we together? Are we together, guys? Give me a thumbs up if you understand. Can I have the thumbs up if you understand? Thumbs up, thumbs up, thumbs up, thumbs up. Is it clear, guys? Thumbs up if you understand. Sharp, sharp, sharp. So that's what is happening. We call it dry adiabatic lapse rate or adiabatic warming, which means for every decrease of 100 meters, the temperature increased by 1 degree. We are used to the common one, which says for every increase in altitude of 100 meters, the temperature drops. When it's with that one, we call it wet adiabatic lapse rate. But here we call this dry adiabatic lapse, adiabatic warming. That's why here it's 20. But when it gets to the coast now, it has been compressed and it heats up. That's why the temperatures are high, which can result in what? In veiled fires at the coast. That's why you also see here on this weather station model, this clear. Why? Because the descending air has been compressed and heats up. So it means there is no condensation, there's no formation of clouds. That's why here it's clear. That's why here you can see there's what? Clear skies. Okay, there's clear skies. Why? Because it has been heat up. Whatever moisture was left in that air that has been heat up is evaporated, which means there's no condensation and there's no clouds that will be formed. That's why you see the weather station model here is showing that it's clear. That's why there's no cloud cover here. Are we together, guys? If we are together, please thumbs up, thumbs up, thumbs up. If you are together, thumbs up, please. All right, let's move on to the next diagram now. This is what we have, guys. Of course, this is what we have. We have got A, escarpment. We have got B. Of course, these are the two diagrams that we have. Indian Ocean, of course, we can see, obviously, what is happening. What is the, okay, this, okay, what we have here. You can see these two diagrams. This is your escarpment. This is your Indian Ocean, which means what is happening? This is rising, isn't it? From the ocean, it rises, goes above the escarpment. Can you see here? Rises, goes above the escarpment. From here, what is happening? This explains more of your berg winds. Of course, from here, going towards in this direction, of course, down, okay? Let's go to the question now. Name the high pressure cell and the low pressure cell indicated on the sketch map that leads to the development of berg winds. What is the answer for 1.5.1? We have already talked about this. Kalahari High and Kalahari High, Kalahari High, sorry, High and coastal low. And coastal low. Are we together, guys? So that is the answer there. Is Kalahari High and coastal low. Okay, let's move on to the second one. Which sketch A or B represents the formation of berg winds between the two? Which one represents the formation of berg winds? Which one? What is the correct answer? That is B. Sorry, guys. Someone has got flu. It can be A. It can be A, guys. Is this one? This is the one. Berg winds. Okay. Remember, we have said that it's moving from the interior where we have got our Kalahari High over the plateau towards this side where we have got what? The coast. That's where we've got the coastal low. Coastal low. So the answer there is B. Do we all understand, guys? Do we all understand? Someone is saying S. Where is the S coming from now? Someone is saying S. Are we together, guys? Nolwande, do you understand why we are saying B? Do you understand why we are saying B? Nolwande, can you respond, please? I saw you right there. Wrong answer there. So are we together? This, remember, when we're talking about, Nolwande, when we're talking about our Berg winds, we say these are what? Okay, let me go back. Check here. Berg winds, we say it moved from the Kalahari High towards the coast. You understand? Which means we have got the hot, dry winds that blow from the interior Kalahari High to the coastal low. That was our definition. Lolwande, are you following? This is our definition. So they are moving from the high over from the plateau towards the coast. That's what is happening. They're moving from the plateau towards the coast, which means if from over the plateau where we have got our Kalahari High towards the coast. So this is the diagram that shows that. Nolwande, do you understand now? Nolwande, do you understand now? Can you give me a thumbs up? Thank you. Thank you so much. Thank you so much. Thank you so much. I don't want anyone to be left behind. All right. Let's move on. Then it's saying now, give reason for your answer in question 1.5.2. Why did we say B? Why did we say B? Why did we say B? Okay. Remember, our air is flowing from the interior towards the coast. Here is flowing from the interior towards the coast. It's blowing from the interior where we have got our Kalahari High towards the coast. That is the reason. It moves from the interior where we've got our Kalahari High over the plateau towards the coast. That is the reason why we said the answer is B. Are you following? Because we moved from the interior towards the coast. Fruity, that's correct. That is correct. That is correct. That is correct. It's moving from the interior, okay, towards the coast, okay. Then let's see 1.5.4. Explain why the cloudless conditions are indicated by the station model X on the sketch map. Why do we have this cloudless condition? Why do we have this cloudless condition here? Remember, I explained this. Why do we have this cloudless condition? Why do we have this cloudless condition? Remember when I was talking about adiabatic warming, for every decrease in altitude of 100 meters, the temperature increased by 1 degree. So it means when the air is descending down the escarpment towards the coast, it is compressed and it heats up. It means there is no condensation that takes place and there's no clouds, hence there's no rainfall. So it's more of an offshore wind. It's more of an offshore wind that is blowing from the interior towards the coast. All right, sharp. Are we fine with that? Okay. So it's descending air. It's more of an offshore wind that is blowing from the land towards the sea. So as it is descending down the escarpment, it is compressed and it heats up. That's how it loses the moisture that it has. So it means there is no condensation that takes place and there is no clouds that are formed. Hence, it is clear. Okay. Because of the decrease of temperature within decrease of temperature. Is the temperature decreasing, Yasha? Is the temperature decreasing? Is the temperature decreasing when it's going down the escarpment? Is it decreasing? Yasha, you are confusing something here. Yasha, can we correct it now? Remember, I gave you an example of this. It's 20 here, but when it gets here, it's 36. That's how it results in veiled fires. So we are saying now, as it is descending down on the leeward side, it is compressed and it heats up. For every decrease in altitude of 100 meters, the temperature increased by 1 degree. So the temperature is not decreasing, it's increasing. At the cost, it will be high. That's why this offshore wind are resulting in wildfires. So Nyasha, can you correct that? The temperatures are not decreasing at the coast, they are increasing. That's how they result in wildfires. Nyasha, are we together? Nyasha Banks, are we together? Can you correct that statement? Please, the temperatures are not decreasing, they are increasing. That's why we end up having wildfires. Thank you. Yeah, there's offshore wind. It's also correct. It's also correct to talk about the offshore wind towards the ocean. There's offshore wind. Obviously, we know the offshore wind, they blow from the land towards the sea or the land towards the ocean. So offshore wind is also very correct. They will blow from the land towards the sea. That's why it's cloudless. That's why we've got clear skies there. Chidiso, that's correct, okay? Let's move on to this one now. In a paragraph of 8 lines, explain how berg winds impact negatively. Let's do this one now. Let me try to reduce it a bit. In a paragraph of 8 lines, explain how berg winds impact negative on the natural environment and suggest strategies. So our question, guys, our answer should be in 2 parts. Number 1, let's pick up negative impacts of berg winds on natural environment, okay, natural environment, environment. Then 2 is on strategies. Okay, are you following, guys? All right, are you following, guys? So if you are going to answer your question and you do not address these 2, let's start by looking at the negative impacts of berg winds on the natural environment. In a paragraph of approximately 8 lines, explain how berg winds impact negatively on the natural environment. What will be the negative impact on the natural environment of our berg winds? Remember, they are associated with high temperatures. Okay, the vegetation will dry out. Nolwande, that's correct. Let's not talk about the crops, guys. Crops are grown through farming, guys. Crops are not natural. They are grown with farm. Vegetation will dry up, is fine. But don't talk about crops, guys. This is to the natural environment. Are you following? The wind, of course, will cause soil erosion. It is also associated with the strong winds. So the wind will also cause what? Soil erosion. Okay? Wind is from erosion from wind. Okay? What else can we talk about? Loss of soil moisture because of higher temperatures. That is to the natural environment. Okay. Wildfire. Wildfire, what will the wildfire do? They can destroy what? The natural vegetation. Okay? So that is the part of the negative impact. How about the strategies? How about the do we all, okay, before we move that, can you give me a thumbs up if you understand the negative impacts? Let's conclude the negative impacts. Do we all understand why I'm emphasizing, guys? Because some of you are ending up talking about the social and the other things that are not natural. Don't talk about the crops if it's talking about the natural environment. Crops are grown, guys, through farming. Crops are grown. Your maize, you grow it, you farm it. So when you're talking about the natural environment, what will happen to the natural environment because of higher temperatures? The vegetation will dry up. What will happen to the soil moisture because of high temperatures? Which means there will be less soil moisture. That is the natural environment. Are you following? What will the strong winds do? They will result in wind erosion by wind. This is what is happening, which is the loss of soil erosion. These are the 3 things that I've talked about in terms of the impacts of berg winds on the natural environment. The high temperatures also can also destroy natural habitats. You get what I'm trying to say? Obviously, we have got some animals, of wildlife that are relying on the habitats within the natural setup. So the moment they are drying up, which means the natural habitats are destroyed. This is the natural. Infertile soil, of course, how best can we explain that in terms of infertile soil? Infertile soil, I'm thinking of soil erosion. Of course, in soil erosion, it also affects the soil fertility. So if you can look at it from that side, okay, it will destroy the fertile soil through erosion, that is by wind, of course. You can also talk about that. What else? So that is the negative impact. How about the strategies now? There's someone who wrote something about the strategies now. So your question is in two parts, which means you need to address both. It's either you write 1, 2 negative impacts and 2 strategies, or 1 negative impact and 3 strategies, or 3 negative impacts and 1 strategy. Make sure it's balanced. Create fire breaks, that's correct. You can also ensure water accessibility, water to extinguish the fire, of course. Build house near water sources. What else can we do? Availability of emergency services, and so on and so on. So are we fine with this? Are we fine with this person? Okay, thank you so much. Thank you so much. Rows of trees, of course. Sharp. So can we move? Let's move on to the next paper now. I want us to move. I'm seeing that our time is moving. Can we do 2024 or 2025? I want to hear from you. Let's do 2025. I'm thinking because I'm looking at our time as well. Some of you are writing tomorrow. Let's do 2025. Let's do 2025. Yes. Let's do 2025. So we are doing 2025 now. Some of you are writing tomorrow. Okay. Let's do 2025. Let me get hold of the paper as well here. I always make sure that I have got all the papers with me. All right, 2025. 1.3. All right, 2025, 1.3. Let's check this one now. Refer to the sketches below on mid-latitude. All right, sharp guys. I think we have said much about mid-latitude. Okay. What can you pick from this? What can you pick from this, guys? From these sketches that we have, what can you pick? Let's talk about the sketches that we have. Of course, we already know what a mid-latitude is. We have already done that, guys. We're just trying to save time. Okay, what can you pick from this? A, by looking at A, what can you pick from A? A. So this is showing, let me just, okay, say what I'm, okay. These are the stages of development. Development of mid-latitude. Okay, let me just be straight. These are stages of development of mid-latitude cyclone. Of course, let me just make sure that I write it correctly. Mid-latitude cyclone. Okay, so let's talk about this now. Let's talk about A. What can you pick? Which stage is A? Which stage is A? That is the initial, isn't it? That is the initial stage. Okay. So what do we have here at 16? What do we have at 16? I saw someone writing the polar front. Okay. The polar front. All right. Then the warm air is coming from where? Warm air. We have got warm air from subtropical high pressure. Okay. Okay. Then we have got the cold from where? Cold from polar high. Okay. Polar high pressure. Okay, high pressure belt. Okay, let me just say belt as well here. All right, sharp. Are you following, guys? So we have got here our initial stage. We have got warm air. We have got our cold air, the cold air from the polar high pressure, that is 90 degrees south. Then we have got our warm air from the subtropical high pressure belt, that is warm air. These are the two things that we have. Obviously here, this is more of your subpolar low. Here, if you can think of it, okay, that is more of your subpolar low. But it becomes what? The polar front. So this is your initial. This is your initial. Here is your what? This is your mature stage. Are you following, guys? Are you following, guys? B is mature stage. This is the initial stage. Are you following? All right. So when you look at these two now, these conditions, which stage are these two conditions associated with? These weather conditions. Which stages are these two weather conditions associated with? These two. Our C and D. Which stage are these two C associated with? C and D. C and D, which stage are they associated with? C and D. C and D. Come on, guys. Come on, guys. These are floods. These are strong winds. That is your mature stage, most guys. That is your mature stage. Come on, guys. That is your mature stage. That is your mature stage. Remember, this is your floods. These are strong winds, steep pressure gradient behind the core front. Think of it. This is associated with the mature stage. That's mature stage. Your floods here. You've got your floods here. Of course, you've got your what? Your floods, which is from heavy rainfall. Okay, let's say heavy rainfall. Let me put it like this. Heavy rainfall, obviously resulting in what? Floods. Okay, then here what we have? You have got strong winds. You can see strong winds. So this is all linked to the mature stage, guys. Come on, come on, come on, come on. This is all linked to the mature stage. Do you understand, guys? Do you understand? This is linked to the mature stage. Are we together? Give me a thumbs up if we are together, or if you are confused, we can talk it out. Are we together, guys? Are we together? So we have got the initial stage. We have talked about it. We have got the mature stage. Obviously, your well-defined what? Cold front. You have got also your warm front. You have your warm sector. You have got your cold sector. All these things, okay? So this is your initial, this is your mature. All these, they are associated with the mature stage. We have got heavy rainfall, floods. We have got strong winds, steeper pressure gradient. So that is your mature stage. Are you following? Are we together? Okay, if we are together, let's go now to our questions now. The first question reads, let's go to our question. All right. What is the name of the boundary between two air masses as shown in sketch A? What is the name of the boundary? What did we say this boundary is? This one. What did we say it is? This one. We said it's a what? A polar front. Okay. That is our what? Our polar front. Okay. That is our polar front. Give one reason why the boundary between the two air masses in the sketch A would form a wave. Give a reason why it would form a wave. Obviously, with that wave comes the low pressure. Why would it form the wave? Especially this is in the second stage, that is the development stage. Why would it form a wave? Remember, we have got two air masses that have got different characteristics, the warm and moist and the cold and dry. Okay, because of the different, thank you so much, Luanda. That is the two different air masses coming from different parts. Obviously, that's how it can form, which results in atmospheric instability. What else? Frictional drag. You can talk about the, what else? Temperature differences. Temperature, let me just try to be simple. Temperature differences. You can talk about what? Frictional drag, frictional drag, frictional drag. You can also talk about what? Wind speed differences, wind speed differences. What else can you talk about? The jet streams, which are upper air movements, jet streams, etc. So anything, but to be simple, let's talk about the difference. Let's say the temperature difference, frictional drag. Remember, these are two air masses with different characteristics. The other one is warm and moist. The other one is cold and dry. So that's why it can result in the formation of a wave. Frictional drag, wind speed differences, the jet streams, these are just the upper air movements, of course. So that's the answer there. Can we move on to 1.3.3? 1.3.3, is it fine? 1.3.3, what is the answer? Are we fine with 1.3.2? Give me a thumbs up. Okay, name the stage of development associated. Okay, that is the mature stage. That's correct. Here is what? Mature stage. Mature stage. Mature stage. That's correct. That's correct. That's correct. That's correct. Let's move on to the next one. Explain how the weather conditions illustrated in photograph C and D develop during the stage in question 1.3.3. How does it develop? How does it develop? How does it develop? How do we end up with the strong winds and the heavy rainfall? How does it develop? We are saying now steep pressure gradient, results in strong winds. Strong winds. Okay. Then how about heavy rainfall? What happens? The upliftment of warm air by cold air causes warm air to rise, condense, form clouds and rainfall. Okay, that's basically what we are talking about, and that is in short. So you need to, okay, steep pressure gradient resulting in strong winds, upliftment of warm air by cold air causes warm air to rise, condense, form clouds, then we have got rainfall. That's basically what we are talking about here. Is it clear? Is 1.3.4 clear? Is it clear? Is 1.3.4 clear? Is it clear? Let's do now 1.3.5. It says, in the answer book, draw a well-labeled cross-section of the chord front E to F in sketch B. Clearly indicate the following: the cross-section, general direction of movement of the mid-latitude, cloud type, and sector. So let's go back. We are drawing the cross-section for this part. This part here from E to F. Only this part from E to F. That's what we are doing. So how do we draw it? Okay, I'll just try to, let me just find space where I can draw this. So we are going to end up with something like this. We are going to have something like this, of course. Then what we have here, we are going, okay, we're going to end up something like this. Let me just try to draw. Okay. Okay. All right. Okay. Then what else? I'm going to indicate here. All right. Okay. Okay, what else do I have? I'm also going to have here on the lower altitudes. Okay, I'm gonna have this. Okay, sharp. All right, let me label now. Sorry. This is the cold sector. Okay, that is the cold sector. Here is your warm sector. Warm sector there. This one is your cumulonimbus cloud. Cumulonimbus cloud. Okay. Then what we have in terms of movement. So here at the bottom, I need to include something here just to show. At the bottom, obviously, it moves from west, which is your W, to east, which is your E. That's how it moves. What else do I need to show? Here is your movement from west to east, which means from here I've got my F. Let me just put F. All right, let me put F where I've put W. I'll put F. F. All right. F. Then I'll E, man, not F. E. Sorry. E. Then here I'll put F. I'll put my F. Okay. Remember, guys, it is from E to F. Obviously, it's west to east, of course, because it's a mid latitude. So you've got your cold front, you've got your cold sector here. Obviously, this is your cold front. This is your clouds, cumulonimbus cloud. It's rising, warm air that is rising. This is within the warm sector, E to F. So that's how you're supposed to do it. Are we together, guys? Are we together? Are we together? Are we together? So you can even label here easterly movement. Easterly movement, or let me just say west to east. Let me try to be simple. West to east. All right. Are you following, guys? So you have to take note. You don't have to draw the whole diagram. You just say from east, from E to F. So this is what I've shown here. Is it clear? All right. If it's clear, I can see most of you are saying yes. Let's move on. Let's move on. Then we have got refer to the sketch and explain the difference in temperature of the air masses behind the cold front and ahead of the warm front will result in the formation of a cold occluded front. Okay, so it's saying refer to sketch B, explain how the difference in temperature of the air masses behind the cold front and ahead of the warm front will result in the formation of cold occluded front. There's something that I want to talk about when it comes to cold occluded front and warm occluded front. Okay, it's like this. Okay, so this is your surface. This is your cold front. And this is your warm front. Okay, I'm gonna do another one. This is your surface. This is your warm front. And this is your cold front. All right, sharp. So it's like this. So here we have got, I'm just gonna add, I'll explain now. I just want to, here I had, here it's cool. It's cool air. Here you've got your warm sector. Warm sector. There you've got your cool air. Cool air. air. There you've got your cold air. Cold air. There you've got your what? Your warm sector. Your warm sector. All right. Sharp. So this is a warm. Okay. The question is saying, okay, I just wanna this is a warm front occlusion. Warm front occlusion. This is your cold front occlusion. Okay, can I say something? Can I say something, guys? The difference, guys, when it comes to the cold front occlusion and the warm front occlusion is here, the cold front touches the surface. Number one, cold front, okay, touch, okay, surface. Number one, there is cold air behind cold front. Cold front. There is also cool air ahead, okay, ahead of the warm front. You can check there. All right. So this is what helps you to distinguish the cold front occlusion. So your cold air will be behind the cold front. Cold air or the cold sector will be behind the cold front. In between, you always have your warm sector. Then ahead of the warm front, you've got your cool air. And your cold front will touch the surface. This one. This is what I'm talking about. This, it touches the surface. This one touches the surface. Okay, so that is your cold front occlusion. You have to know the position of your cold and cool air. The position of your cold and cool air. Cold air behind the cold front. Then warm sector will always be in between. Then ahead you've got cool air. That is your cold front occlusion. Then your warm front occlusion now is the opposite. Your cool air is behind the cold front. And your cold air is ahead of the warm front. The warm sector remains in between. Are you following, guys? I wanted you to know the difference between your warm front and your cold front occlusion. Are you following? Are you following, guys? So you have to know the location. Where is your cold air? Where is your warm air? Where is your cold air? Where is your warm? The warm air will always be where the warm sector is. The difference only is under your cold front occlusion, cold air is behind the cold front and cool air is ahead of the warm front. Under your warm front occlusion, the warm front touch the surface. So we are saying here now, when it comes now to your warm front occlusion, we are saying the warm front touch the surface. That's basically what we are saying. Then we are saying there is cool air behind cold front. Cold front. Then there is cold air ahead of home front. So the only difference between the two now, your cold front occlusion and your warm front occlusion, is the positioning of your cool and cold air. That is the difference. And also which front touches the surface. That's what differentiates your cold front and your warm front. So this is your cold front occlusion, cold air behind the cold front, and the cold front touch the surface. Ahead there is cool air. The warm sector will always be in between. So what touches the surface determines the type of occlusion. So cold front is touching the surface. That's why you see this is your cold front here. So cold front touch the surface, cold air behind the cold front, cool air ahead of the warm front. Then your warm front occlusion. Warm front touch the surface, you can see here. The warm front here, it's more straight. You can see it's touching the surface. Of course, then you've got what? Cool air behind the cold front. This is the cool air here. The cool air that is behind the what? The cold front. Then ahead, what do you have? You have got cold air ahead of the warm front. Are you following, guys? Is it clear? Is it clear, guys? I want to make sure you understand because I want to make sure you understand. Okay, so to answer the question now, here I wanted you to understand the difference between your cold front occlusion and your warm front occlusion. That's what I was trying to explain. All right. So are you all fine with the difference between your cold front occlusion and your warm front occlusion? How do you identify the two? Are you fine now? Give me a thumbs up if you understand how to differentiate the two or how to identify. Okay, thank you, Demon. You said yes. I want at least confirmation of 3 people. Yeah, thank you, Nolwande. You said you understand. Yebo. That's cool. That's good. That's good. That's good. Yasha, thank you. Thank you. Sharp. So let's answer the question now. The question now is saying, refer to sketch B, explain how the difference in temperature of the air masses behind the cold front and ahead of the warm front will result in the formation of cold front occlusion. So the way you respond to this question now is, number one, the air behind the cold front is colder than the air in front of the warm front. The same thing that I was talking about. The air behind the cold front is colder than the air ahead of the warm front. That is the first thing that you can talk about. So it means now, what will the cold air do now? Since it's more denser, it's going to undercut the warmer air in front of the cold front. Because what makes this to be warmer is the difference in temperature. Because this is lighter than this. So this is colder than the air ahead. So the fact that this is colder, it makes it more denser. This one becomes more lighter. So it means it's going to be undercut. Once it's undercut, it's going to be uplifted. Why? Because this one is colder and denser. This one, this is what makes it lighter even if it's cool. That's basically what we are talking about. So air behind the cold front is colder, which makes it more denser. So it will undercut the air ahead because it's warmer. That's basically what we're talking about. Okay. Are you following, guys? So that's how you can respond to that question. I studied the mid-latitude cyclones more in the ASCII tropical. Okay, sharp. So, okay, guys. So, are we together with this one? I've just explained now. Are we together? So, it's a matter of knowing the positioning. How does how do we get to a situation whereby the air above is uplifted? It's because of the difference in densities. This is more denser, so it undercuts this ahead. Then that's how it happens. Okay. So let's do 1.4 now. Tropical decay. Remember now, we are doing 1.4 now. The first thing, guys, remember when we're talking about the correct tropical cyclones in general, we said they are named what? Alphabetically. Do you still remember? We talked about them being named alphabetically. So obviously, this name decay is supposed to say something to you alphabetically. Okay, named alphabetically. Let me just say named alphabetically in the season in which they occur. So obviously, what comes to your mind when you hear this word tropical cyclone decay? What comes to your mind? What comes to your mind? What comes to your mind? Is cyclone number what in this season? What comes to your mind? What comes to your mind? No. We are talking about the name first. Fourth cyclone. Why? Because A, B, C, D. They are named alphabetically. Remember, we've talked about that when we started. I mean, okay, fourth cyclone. That is cyclone decay. A, B, C, D. They are named alphabetically. They are named what? Alphabetically. So we are saying we have got cyclone decay, which means it's the fourth in the season now. D, A, B, C, D. The fourth letter in the alphabet. Okay, sharp. Let's go to this one now. Tropical cyclone decay was first observed off the northeast coast of Madagascar. Okay, obviously, what is telling you already, this is more common in the Mozambican channel, of course, more common in terms of location. Already, by mentioning Madagascar, you already know now that it's within the southern hemisphere. Obviously, what comes to your mind is this is within the southern hemisphere, because Madagascar is in the southern hemisphere. Are you following? Southern hemisphere. Why? Because southern hemisphere. Why? Because of the way Madagascar is located. Okay. Of course, along the Mozambican channel as well. I can add that. All right. Mozambican channel, which means over the Indian Ocean. Mozambican channel. Okay. All right. Over Indian Ocean. Okay. These are some of the things that should come to your mind. All right, let me try to take this up. Okay, over the Indian Ocean. Sharp. All right, let's read this now. Conditions recorded on 8 January 2025. Pressure at the center. All right, pressure at the center is, which stage is this, guys? Remember, from our formative, it's above 1000. Immature, slightly below. Mature, far below. Dissipation is going up. So which stage is this now? Which stage is this? Stage of development of our tropical cyclone. Which stage is this? Which stage is this, guys? Which stage is this? From the number, this is the immature stage. Okay, that is the immature stage. Okay. That is it's not the initial, it's the immature. Look at the number 996. Remember, now it has dropped below 1000. So now is the immature stage. Is there anyone confused with this? Is the immature stage. Immature stage, because remember, the sequence is formative, above 1000. Immature, slightly below. Mature, far below. We're talking about what can be 950, 970 something. Then dissipation is going up again. So you should know the changes in terms of pressure. It's up, below, far below, then it goes up. So this is your immature. Stage. From this, that's what we can pick. Okay. Thank you. And also with the picking up of the wind speed as well, 75 kilometers per hour. So that's correct. Let's move on to the next one. He's saying conditions recorded on 13 January. Pressure in the center, 976. Which stage is this now? Which stage is this now? On 13. Which stage is this now? This is far below now, which means now is the mature stage. So you have to know formative, immature, mature, dissipation. Okay, you have to know. So it's above, below, far below, then it goes up again. So that is your mature. You can also see as well with the wind speed. Here, steep pressure gradient. No, it's not immature. This is 976. Nolwandle, this is mature stage. It's not immature. It's far below 1000 now. So that's what makes it to be mature here. On the 13th of January. On the 8th, it was mature, but on the 13th, it's now, on the 8th, it was immature, but on the 13th, now it's mature stage. Look at the pressure. This is 996, which is slightly below. It's starting to drop in the mature stage, but in the immature stage, now, it has dropped now to 976. So this is your mature stage. Are you following? Are we following, guys? Give me a thumbs up if you are following. Give me a thumbs up. Give me a thumbs up. Nolwandle, are you with me? Okay, thank you. Then here now, I want confirmation from Nolwandle so that I know we are moving at the same pace. I don't want to leave anyone confused. Could you please repeat it? I'm saying, Nolwandle, if you look at the stages of development, in the formative stage, it's above 1000. In the immature, that's when it starts dropping. So it's slightly below. That's why you've got 996 hectopascals, which suggests that it's the immature stage. It's the second stage in our tropical cyclone development. Then here on the 13th of January, it's far below now. That is your mature stage. Then the last one is dissipation. It starts to rise again. So the changes in terms of pressure, formative stage, it's above 1,000. Then immature is slightly below. It's starting to drop. Then mature is far below. Then dissipation, it rises again. So that's why I'm saying here on the 8th of January, it's the immature stage because it's slightly below. This is 996. There's a difference of 4 hectopascals for it to get to 1,000. That's why we are saying it's what immature stage. So when it gets here now on the 13th of January, it's fully developed now. You can see now with the winds, wind speed, and plus also what we have in terms of pressure, which is 976. That it now explains the mature stage. Are you following? Now, is it clear now? Nolwante, is it clear now? Thank you, thank you, thank you, thank you. So what we have here now, remember when we talk in terms of location, we said here from 0 to 5 here. Remember what we said? We said here there is no Coriolis force. Coriolis force. There is no Coriolis force. So that's how it starts developing from 5 degrees going downward. You understand? Because there's no Coriolis force. So the presence of the Coriolis force, we want it because this is what caused the formation of a vortex, development of an eye. This is what gives more energy to our cyclone as it starts to develop. So from 0 to 5, there's no Coriolis force. Coriolis force is the force that is responsible for the deflection of wind. In the northern hemisphere, it's deflected to the right. In the southern hemisphere, it's deflected to the left. That's why you see it's going towards the left here. You see here, it's deflected to the left. So southern hemisphere here, southern hemisphere is deflected to the what? To the left, left deflection. That's how now it moves from the east to west, being driven by the easterlies. So that's what is happening now. It's left deflection. That's why it's moving from 5 degrees south, going towards this direction until it's going to reach the 30 degrees south. Then it starts heading towards the east again because it would have reached land where there's more friction, where there's less moisture, where there's no latent heat. You understand? So that's what is happening here. They are trying to show you where the tropical cyclone can start developing from 5 degrees south. Why does not develop from 0 to 5? Because there's no Coriolis force. This is the force that's responsible for the deflection of wind. So that's why I say now from 5 degrees going downward now, that's where we have got deflection. That is deflection to the left. Here we have got Coriolis force. Here, Coriolis force is here. Coriolis force, okay? Coriolis force present. Present, okay. From 5 degrees south. Okay. Are you following, guys? Are you following on this one? Are you following what I'm trying to say here? Are you following? Are you following, guys? Give me a thumbs up if you are following. Give me a thumbs up if you are following. Can I have the thumbs up if you are following? Thank you so much. Thank you so much if you are following. Let's go now to our satellite images. Our satellite images, obviously, the same thing, guys. Madagascar, of course, I've already demonstrated this. You can see in terms of, it's just showing you that it's what? Same applies with here. You can see in terms of circulation, that is clockwise. So it's showing you what? Clockwise. So which means it's in the southern hemisphere. So it's showing you clockwise there. That is in the southern hemisphere. Clockwise circulation. That is what? Southern hemisphere. Southern hemisphere. All right. Southern hemisphere. Are you following? Southern hemisphere. That's what we are working. Okay. Can you see? Of course, here, because of the presence of the development of forward left quadrant, already what comes to your mind is this one is the mature. Mature stage. Okay. Let's see now. So this is 13. So this one is the immature. We have already talked about it. That is the immature stage. All right. Are you following, guys? I want us to go to the questions now. This is straight now. If it's fine, give me a thumbs up. If I have managed to explain it, to clarify these diagrams, you give me a thumbs up. I think it's fine now. We have looked at this. I've explained. You now have enough information. Let's go to our questions now. So the first one is saying, according to the fact file, at which stage of development was Tropical Cyclone Dikeledi on 8 January 2025? Remember, we said it's what? What is the answer? We said it's immature stage. That is our answer there. So 1.4.1 is immature. Immature stage. Okay. Then number 2, give reasons for the fact file to support your answer on question 1.4.1. What is the reason? Remember, we talked about the pressure. Pressure, okay. In the center, what is it? Okay, is 996 hectopascals. We have already talked about that one. Okay, what else can we talk about? Pressure. We want to justify that it's immature. It's the immature stage. So I don't think the circulation will justify that. But we are looking at number 1. Let's look at the wind speed. The wind speed. So what justifies that it's immature stage is the wind speed and the pressure. Those are the two. The maximum speed and the pressure. This is what justifies that is the immature, not the clockwise. Okay. So what is relevant there is the wind speed and our pressure, okay, and the wind speed as well. Okay, our wind speed, let's talk about the wind speed as well. Wind speed, that is 75 kilometers and 5 kilometers per hour. So these are the two that justify that it is immature stage. Are you following, guys? Are you following, guys? Give me a thumbs up if you are following. Give me a thumbs up if you are following. Sharp. So 1.4.3, it reads, explain why the tropical cyclone Dikeledi developed between 5 degrees to 20 degrees south of the equator. We have already talked about this. What is the answer? 1.4.3. Why did it develop from 5 degrees? From 5 degrees to 20? 1.4.3. Because of the presence of Coriolis force. Coriolis force. Because of the presence of Coriolis force. This has nothing to do with the shifting of the ITCZ Nolwandle. This is because of the presence of the Coriolis force. Remember when I was explaining here, guys, I said from 0 to 5, there's no Coriolis force. So the reason there is because of the presence of the Coriolis force. That's why it developed there. Because of the presence of the Coriolis force. Or you can also talk about the latent heat. Anything that is the conditions, okay? The latent heat that is produced after condensation, okay? You can also include that. Latent heat, okay? Released during condensation. Released during condensation. Condensation, that could be another reason that you can talk about. But mostly, okay, because of the presence of Coriolis force, latent heat released during condensation. So these are some of the reasons, okay, that you can talk about. You can also talk about the higher temperatures that promotes evaporation. You can add higher temperatures, higher temp that promotes evaporation. Okay, latent heat is produced when condensation takes place. So it gives more energy to the tropical cyclone. Latent heat is the heat that is energy when condensation takes place. So it gives more energy to the tropical cyclone. I don't know if you are following. Zandi, are you following? Latent heat is the heat that is produced when condensation takes place. It gives more energy to the tropical cyclone. Okay, so this is how you can respond to this because of presence of Coriolis force, latent heat. Yet on this question, they are indirectly asking you about the conditions necessary for the development of the tropical cyclone. That's what they are trying to do here. E.g., okay, NB. These guys, what they are trying to do, okay, they are indirectly asking for the condition necessary for the development of tropical cyclones. That's why I'm always saying, guys, you have to reason. You have to reason. This is what they're doing. They're indirectly asking for the condition necessary for the development of tropical cyclone. They're saying, explain why tropical cyclone developed within the, what conditions are they that helps in the development of cyclone Dickeled. So they are indirectly asking you for the condition necessary for the development of tropical cyclone. That's why we have to cite this because of presence of Coriolis force, latent heat released during condensation, high temperatures. You get what I'm trying to say? So they are indirectly. The questions are not direct now, guys. You have to think. You have to have a critical mind so that you can be able to pick some of these things. Okay, let's move on. Then here, refer to the satellite C and D. Okay, 1.4.4. Describe the weather conditions associated with the forward left quadrant on the satellite image. Guys, this one, let's just just saying, describe the weather condition associated with the forward left quadrant, dangerous semicircle on the satellite image D. What are the weather conditions associated, all right, with this? What are the weather conditions associated with this? Let's talk. Heavy rainfall, that's correct. What else? Thunderstorms. What else? Lightning, hailstorms, strong winds. You understand? You can talk about all those things. You can talk about those things. Are we together, guys? Are we together with this one so that we can move on? So we are talking about what? Heavy rain. Heavy rain. Strong winds. What else? Lightning, etc. Okay, and so on and so on. This is just 2 marks, so we are fine then. Then the last one. Explain why tropical cyclone Dickeled intensified from 8 January. What is happening? Inactivity detected in your life, complete verification. What do I need to do now? It's saying verify. I mean, go to Live Studio to verify. Okay. All right. What do I need to do here? Okay. No. Okay, sure. Okay, sure. Okay, sorry guys. So are we fine with 1.4.4? Let's do now 1.5, 1.4.5. Explain why the tropical cyclone Dickeled intensified from 8 January to 13 January 2025. Why did it intensify? Explain why cyclone Dickeled intensified from 8 January to 13 January. Why did it intensify? What can we include here? What can we include? Less friction. We're talking about less friction over the ocean. What else? More. What else? What else? More latent heat. More latent heat. More latent. More latent heat. What else can we talk about? More latent. I wanted to. Okay. More latent heat. Okay. What else can we talk about? More evaporation. Evaporation. Okay. etc. Okay. More evaporation and etc. Evaporation. No decrease in temperature. Remember, it's going over the warm ocean. So the temperature has to be 25, 26 degrees and above. So there's an increase in temperature, not decrease. Sadly, the increase in temperature, not decrease. Is the increase in temperature, not decrease. So do we all understand 1.4.5? Give me a thumbs up. If you understand 1.4.5, give me a thumbs up. Are we fine with 1.4.5? We want to finish now. 1.4.5, are we fine with it now? Yes, I think we are. Give me a thumbs up if you are fine with 1.4 so that we can move to 1.5. All right. What do you want me to repeat now? Here we are saying now what is meant by to intensify. Okay. Explain why. All right. Look, no problem. I'll explain now. All right. What happens? Let me put it this way, Norwanje. What happens when the tropical cyclone reaches land? What happens? It dissipates, isn't it? When it reaches land, I want to try to explain to Klope and Norwande what happens when the tropical cyclone reaches land. What happens? There's more friction, isn't it? Less latent heat. Are you following? So this what is causes to lose energy, to dissipate. It won't be as destructive as what it will be when it is still over the ocean. Let's talk about the Mozambican channel. Now, because it has reached the conditions that are existing now, because it has reached land. Are you following? Are you following? Nolwande, can you respond so that I can know whether I'm explaining it, I'm not creating more heat than light? Nolwande, are you following? Okay, so that's what is happening. So we are saying now when it gets back to the Mozambican channel, the conditions that are there, it gives more energy to the tropical cyclone. That's how it intensifies. Because the conditions that are there, it gives more energy to the tropical cyclone. You understand? Like your temperatures, which are supposed to be above 27 degrees Celsius, like evaporation, which provides more moisture. Okay, like what else? Less friction. You understand? Like the release of the latent heat, which gives more energy. So that's how it becomes intensified. You understand? It becomes more destructive. You understand? It has got more energy. That's basically what you're talking about. Is it clear now? Exactly. Sandy, it's fine. You have simplified. Make it stronger. This is straight into the point. Yeah, that's it. That's correct. Yeah, that's the simplest definition. Thank you, Sandy. Thank you so much. Thank you so much. That's the simplest. So, Nolwande, are we fine now? So that we can move on to 1.5? Are we fine with that explanation of intensifies? Make it stronger. Thank you, Sharp. Thank you so much, Transley. Thank you so much. Thank you so much for clarifying that. Refer to the synoptic weather map below showing South African berg winds. I think we have done enough about berg winds, guys. This is becoming late. Okay, but let's just do it. Let's just finish up. Okay, so that's what we have. We have already talked about berg winds. What are berg winds, guys? If you can answer, just tell me what it is. What are berg winds? If you still remember, what are berg winds? In which seasons do they occur? What are berg winds? In which seasons do they occur? Warm, dry winds, okay, that blow from the interior to the coast. All right, sharp. So the season is winter. This is in winter, né? Okay, sharp. How did we come to the conclusion that is winter? Remember here, this is your Kalahari High. Here, Kalahari High. Okay. Then what we have here, we have got our coastal low. We have got our coastal low. So already these are the two things that we need. And this obviously is in winter. Why? Because our Kalahari is more dominant here. Kalahari is more dominant. Kalahari is more dominant. We've got our coastal low at the coast. So it's a winter season. That's where we have our bergwins, okay? It's winter what? Season. It's winter season. That's where we have got our bergwins. This is basic. We have done a question. We already done a question on bergwins. I think we did that in detail. By now we should know. Okay. The other thing that we can also be able to tell that it's winter. You can see from here, how can we also tell that it's winter? We are looking now at, look at the calm, clear skies, okay? Calm weather conditions in the interior, calm weather conditions, inland, okay? Let me say inland, something that we can also look at. We can see the clear skies. Here you can see, what else can we also support that? You see, you can see the approaching cold front. You can see here, look at the weather condition in Cape Town. So there is an approaching cold front, approaching, whether I want to say mid latitude, it's the same thing, approaching cold front. You can see with the weather condition here in Cape Town, approaching cold front. Of course, you can also talk about your, if you want to see the coastal low is ahead of the cold front in winter. These are some of the things that you can actually talk about. Okay. And so on and so on. All right, let's get to the question now, guys. It's becoming late now. Some of you are writing tomorrow. So it's saying, name one South African city indicated on the synoptic weather map that is experiencing bergwind conditions. Which city is indicated on the map? Which city is indicated on the map? Can you see here? East London and Durban. These are the cities that are experiencing the bergwind condition. So you've got your Durban and East London. Okay. Okay, these are the two. Then the next one, give evidence from the synoptic weather map to support your answer in question 1.5.1. What evidence is there on the map? Can you see the large temperature range? Large temperature range. You can also talk about the large temperature range. Large temperature range. Okay, something that you can talk about. What else can you talk about? What else can you talk about? Clear skies, of course. These are straight and to the point. Okay, clear skies, of course. Clear sky. Okay, sharp. I think this one is fine. We want to finish now, guys. It's getting late. You guys are supposed to prepare for your exam tomorrow. Explain the process that leads to bergwins being warm and dry. What is the process? Remember, I once mentioned this. This is adiabatic warming. Adiabatic warming. Okay. Adiabatic warming, which means for every decrease in altitude by 100 meters, the temperature increase by 1 degree. So that is what is happening. which means as the air is descending down the mountain, what happens? It is compressed and it heats up. That's how it becomes warm and dry. Adiabatic warming. We also call it the dry adiabatic lapse rate. For every decrease in altitude of 100 meters, the temperature increased by 1 degree. Do we understand, guys? Are we fine with that one? Or do you want me to explain further? Are we fine, guys? We are saying for every decrease in altitude of 100 meters, the temperature increased by 1 degree. So this is what we call the dry adiabatic lapse rate. This is what we call the dry adiabatic lapse rate. Okay. What I'm trying to say is, okay, I'm going to give this as an example. Okay. All right, I'm going to give this as an example. Let's say here, that's where our plateau is. Plateau, okay. This is where our coast is. Coast. All right. So what I'm trying to say is, here, let's assume, let's say our temperature is 20 degrees. Of course, when it reaches there at the coast, let's just give it, let's say 36 degrees. What is happening now is, as it is descending down the mountain here on the leeward side, it is compressed and it heats up. It is compressed and it heats up, which means for every decrease in altitude of 100 meters, the temperature increased by 1 degree. That's why here the temperature here is 20 over the plateau, but when it reaches the coast now, it has increased to 36, which results in veiled fires. So that's what is happening. So Zandli, do you understand now? That's what is happening. It is adiabatically warmed, which means as it descends on the leeward side of the mountain, for every decrease of altitude of 100 meters, the temperature increased by 1 degree. We call that dry adiabatic lapse rate or adiabatic warming. That's what it is. So that's why it results in warm and dry wind, which is more of your offshore because it's coming from the land towards the sea. Okay. Is it fine now, Santley? So that we can move on to 1.5.4. Is it fine now? Thank you. Sharp. Let's do the last one now. The warm and dry conditions. The warm and dry conditions. The warm and dry conditions. The warm and dry conditions can influence veiled fires, which means can cause veiled fires. In a paragraph of approximately 8 lines, suggest sustainable strategies that can be put in place to reduce the negative impact of veiled fires. So here we are more interested in the strategies. Focus on what? On strategies. Strategies. Focus on strategies. That's what we need. So what could be the strategies that we can put in place? What can we do? Remember, guys, the paragraph question. Can I say something about the paragraph question? When you're answering paragraph question, please make sure that you explain them in full. You explain the point and the qualifier. Do not write in point form. Write in form of a paragraph. Write a paragraph. Give as much information as possible. Your points should be pregnant with information. Give as much information as possible. Don't be vague. So that's what a paragraph question requires you to do. Give as much information as possible. Do not write in point form. Write in form of a paragraph, but now need to make sure that you give as much information as possible. Okay, now we don't have space. Say we get you. So thank you so much, guys. Thank you so much, guys. I think focus on strategies. That is the main thing. Can we just list some of the strategies? Then we call it a night. Can we just mention? Let's just mention them. Then we call it a night. What can we do? What strategies can we put in place? We need about 4 or 5. Then we know that we are covered. Build plenty dams, firefighters to control, early warning system, educate, train people. That's correct. What else can we do? Build water storage facilities. You're educating the communities about strategy they could implement. That's the same thing that you have talked about there. Improve access to firefighting equipment, and so on and so on. So, boys and girls, I think for today, I think we can call it a night, guys. Thank you so much, guys, for Thank you guys. Thank you guys for attending this live. Thank you so much, guys. I think this takes us to the end of our life. Thank you so much, guys. Starting tomorrow, we are doing geomorphology. Tomorrow, Wednesday and Thursday, it's geomorphology. Then Friday, we'll take a break. Then Saturday, we are going to do GIS. Then Monday, we are going to do map interpretation. Then Tuesday, we are going to do map calculation. Please, guys, in your numbers, can you go on my bio, click on my YouTube channel and subscribe? Thank you so much, guys. Thank you so much. I really appreciate. The only thing you can give me, guys, is to go and subscribe on my YouTube channel. Please, guys, go and subscribe on my YouTube channel. Thank you so much, guys, for attending. I'll see you tomorrow. Tomorrow we are starting with geomorphology. We're starting at 8. We're starting at 8. Tomorrow we're starting with geomorphology. Thank you so much, guys. Go and subscribe to my YouTube channel. You just click. You are not paying. You just click on the subscription button. That's all what I'm asking you to do, guys. Thank you so much. Thank you so much, guys. Thank you so much, guys. So tomorrow we are doing geomorphology. For the grade 11s, don't worry, guys. I think I've released the short question video. So tomorrow, grade 11, I'll release another upload for the 15 marks question. So don't worry, you're covered in that regard. Okay. So thank you so much, guys. Please click on my bio. There's a YouTube link there. And just subscribe, guys. You are not paying anything. This is free. Just to subscribe. I only want subscribers on my YouTube channel. So you just click there. Thank you so much. Thank you so much. Thank you so much. Does paper one? No, paper one does not consist of economic geography. It's paper two. Paper two is settlement and economic geography. Paper one is climate and weather and geomorphology. Paper one is climate and weather and geomorphology and map work. So climate and weather, 60 marks. Geomorphology, 60 marks. And your map work, 30 marks. For your paper two, it's settlement, 60 marks. Economic geography, 60 marks. Then 30 marks for map work. Thank you so much, guys. Please click the link for my YouTube channel or my bio and subscribe, please, guys. Thank you so much. Thank you so much. Thank you so much. Have a blessed evening. I'll see you tomorrow. Before you go, can you tap the screen, guys? Let's get to 20,000. Before you go, let's tap the screen. Let's tap the screen. Thank you. Thank you so much. Thank you so much. Thank you so much. Thank you so much. Tap the screen before you go. Take the screen before you go, guys. Let's get to 20,000. Now it's 9. Before you go, just tap the screen. Tap the screen. Tap the screen. Tap the screen. Thank you so much. Thank you so much. So we're gonna use the same papers, guys. The content is the same, guys. What these guys do is they are just recycling the question. They are just recycling the question. The content is the same. So we can use the same paper that we're using tonight for tomorrow geomorphology. Please tap the screen before you go. Tap the screen, tap the screen, tap the screen. Tap the screen, guys, before you go. Tap the screen, tap the screen, tap the screen before you go. Thank you so much. Thank you so much. I really appreciate. Let's tap the screen. We are on 11K now. Let's get at least to 20K. Likes 20K. Now I'm seeing 11K. Let's tap the screen before we go. Thank you so much. So tomorrow, let's make a date, same time, 8 o'clock. We are doing geomorphology. Wednesday and Thursday, it's geomorphology. We start with the short questions. Then the next day, we do the 15-mark questions. So tomorrow is the short questions, but I'll try by all means to give as much a deeper analysis, explanation of the concept. So make sure tomorrow you are there, 8 o'clock to 10 o'clock. Thank you so much, guys. Thank you, guys. Before you go, just tap the screen. Before you go, just tap the screen. Before you go, just tap the screen, guys. Before you go, just tap the screen. Thank you so much. Thank you so much. Thank you so much. Let's get to 20K. I've got 12K now. I'm seeing 12. Tap the screen before you go. Thank you so much. Thank you so much. I really appreciate. I really appreciate. Thank you so much. All right, guys. Let's call it a night, guys. We have to sleep now. It's late. You have to sleep. You have to sleep now. It's late, guys. Thank you. See you tomorrow. Good night. Thank you so much. Good night.